So, bromine, safety concerns, transfers only in the hood. You got that one, right? So you only transfer bromine in the hood, and the bromine burn solution is in the same hood that the bromine is in. If you get bromine on your skin, apply immediately. If you break the bottle that has the bromine in it, run away. And then tell me.
Makes for a great Monday.
Sounds so scary. If the bromine bottle somehow is dropped and it's not dropped inside of the hood, we will all evacuate. Okay? Without delay. Don't break up this.
Hey, the feeling next to the
Okay. So the alkyl will react with the halogen in light. The reaction rate depends on the stability of the free radical intermediate. What is the hybridization of a free radical? Look, I found markers. Yeah, somebody's wasting their budget. Hey, it works. Okay. So for example, a methyl radical. How many electron domains? Did you say one? What is an electron domain? Wow. A bond or a lone pair is a single electron domain. A bond side or an electron domain. Sorry, a bond side or a lone pair is an electron domain. It is a pair.
Yeah.
So how many electron domains? 3. So yes, this has 3 electron domains. Therefore, the hybridization is
This one too.
sp2. The number of electron domains corresponds to the number of letters, 1 S and 2 Ps. Okay. So that's sp2 hybridized. What about for methyl cation? Three, yes. And then the hybridization is 2. So if cations are more stable when they're more substituted, what do you think about radicals? They're going to be the same, they're going to be different. They're the same. The more substituted, the more stable. So that rate of reaction depends on the stability of the free radical intermediate, which follows the same trend as cations. So the more stable the free radical, the faster the product will form. We're going to be doing this in the following way. Add 1 milliliter dichloromethane, also not good for you. Also, don't spill it on yourself, don't breathe it. Okay. Anybody been reading Silent Spring? New Silent Spring journals. How many of those Silent Spring journal molecules had halogens on them? Are halogens good for us? No. Okay. To each tube, add 0.25 milliliters of the different aromatic hydrocarbons. Swirl and mix. Your hydrocarbons are, well, shoot. I'm just gonna put it over here. Toluene, which is a benzene ring with a methyl group. Yeah, he does. I hope he doesn't breathe it in.
Sometimes I accidentally get it on my hands and I get it in.
It can make you high, but most things that can make you high make you sick. So it is dangerous. Yes. Ethylbenzene. Isopropylbenzene. And T-butylbenzene. Okay. These are your molecules. What radical intermediate are they going to form? The radical will always have the position of the carbon adjacent to the ring if possible. So as long as that carbon has any hydrogens, it'll take one and put a radical. For T-butylbenzene, that's not possible. But do you know what is possible? Rearrangement. And some of you guys will see this rearrangement occur, and some of you will not. So it'll rearrange by moving this methyl group over there. So there's that methyl group, and the radical is now at the Y junction. Most, I would say 90% of the class will have no reaction with T-butylbenzene. There will be no color change. This is, oh, did I mention this is going to be observed by color change? And the stability of these radicals is the same as cations. So the most stable and the fastest reacting is the most substituted. We would expect isopropylbenzene to react the fastest. Tertiary allylic, secondary allylic, and primary allylic are our radicals. Tertiary allylic is the most stable. This one, the color change will occur almost immediately. I think I've asked you to make tables. If you read the rubric, it asks you to provide a table of what the substance is and how quickly you observe the color change. So you're going to record how long it takes for the substance to react and for you to observe that color change, record the time of the bromine addition to the nearest minute, and then the approximate time of when it becomes colorless. This one will occur almost immediately. The other ones should all be done within 15 minutes. So that's why I say start with this one. It's super fast. And once you do the bromine addition, you just have to occasionally glance at it. You can be doing something else while you're waiting.
Recording the time of the bromine addition? Like,
I mean, to the nearest minute. So it's only going to take you like, you're adding it dropwise, right? In the hood, add 0.5 milliliters. Yeah. So you're in the hood, you have all your 4 test tubes there. You add 0.5, 0.5, 0.5, 0.5. That takes maybe 30 seconds. When you finish adding the last one, there's this time. Okay. You cap them all and you leave the hood, you let the next person go. Okay. Set them aside. The closer they are to a light source, the faster the reaction will occur. So if you want to put them on that top bench. And then arrange the 4 hydrocarbons in order of reactivity and compare your results with your predictions. Of course, I made the predictions for you. Then you should be working on your Lycopene Lab. This will by far take the most time today. And it's really not going to take that much time once we get to the column. Isn't that right, our lovely Valerie TA? The column didn't take that long, did it? 30, 40 minutes. Yeah. So we're at 15 plus maybe 40, 65 minutes of lab there. Follow the directions to the best of your ability. If your sample has completely evaporated, add 1.1 to 0.2 milliliters of hexanes and go from there. Okay, you're not adding, so the first eluent is hexanes. You're putting that down the column until everything is wet. What are we doing? Are we doing a full? We're only making it so that it's wet, and then we add the sample, I think. Once the alumina is completely soaked with hexanes, allow it to drain to the top of the sand, then add your extract from ketchup and allow that to drain to the top of the sand. Then add 2 to 5 drops of hexanes and allow that to drain to the top of the sand. Then you can just add hexanes dropwise until you've used all 10 milliliters of hexanes, etc. Your molecule should elute in the 5% acetone. So once you finish 10 milliliters of hexanes, you're going to add 5% acetone in hexanes, which has already been pre-made for you. And at that point, the lycopene should come out. Is that correct, Valerie? This is the one that you made, isn't it?
No, it's not.
It's not. That's not correct. It's 10%, right?
We're not using
5%. We're using 10%. I must not have had the change in the document that you gave me. So online, go to modules. This. Download. No, it's not the right thing. No.
it should be all for now.
The file should be attached.
Yeah.
Okay. Let's go to snip. New. Copy. I swear I did this before once. Okay. Petroleum ether. 1% acetone and petroleum ether in the column. You're going to let that drain, then you're gonna add the ketchup extract, then you're gonna let that drain, then you're gonna add more petroleum ether. And the point of that is that you're rinsing the hexanes with the ketchup down onto the column. So that's why it says only 2 to 5 drops. When that drains, then you can keep the column full until you've used 10 milliliters of petroleum ether. The lycopene should come out when you start step 24, which is you're going to let it drain and switch to 10% acetone in hexanes. And you should see a yellow eluent or eluate. Even though it looks red to orange on the column, it will come out as a yellow solution. So you're going to take the second yellow, and you have UV vis on your desk. You guys are going to be doing your own UV vis analysis. Mr. Abels is not going to do it for you. You guys are going to do it. So if you have questions about that, you can ask me or Valerie. I think we're setting up the UV vis because I doubt Mr. Abels turned them on or set them to the correct wavelength. But the instructions are also there. Just let us know when you're ready to do that. This is sort of what it looks like on the column. It's this red yellow color, and then when it elutes, it's this yellow. Unsaturation in commercial products. You know what this is? This is taking an alkene and adding Br2. You know what that does? From chapter 6. What happens when we add Br2 to an alkene? It becomes dihalogenated, right? Remember, we have so if I give you propene plus Br2, it makes remember. Good. Don't scare me, okay? So you're testing to see if these commercial products have double bonds. Bromine is brown. If the brown color goes away or dissipates, that is an indication that that commercial product had molecules that contain double bonds. Okay. The solvent here is going to be CCl4. It is carcinogenic, you know. So our bromine is bad for you, but also the CCl4 is bad for you. Use it in the hood. Decolorization of the dichloromethane layer that contains the commercial product is going to indicate that you did have some unsaturation. You can rank how unsaturated they are. Okay. Don't do more than 20 additions of bromine. See the process that we're recommending. You're only going to test 3 commercial products. Mr. Abels has something like 10 out there, and he used to make you do all of them. We ain't got time for that. Pick 3 commercial products, report which 3 products you're testing. Dissolve 1 drop of your commercial product, approximately 30 milligrams, in 0.5 milliliters of dichloromethane, and then in the hood, add 0.5 milliliters of saturated bromine water, cap it, cover it with parafilm, take it out to your desk. At that point, you can shake for 10 seconds. Do not invert. These lids often leak. Okay. So don't invert. You can do the finger shake or the sideways shake. All right, so you're going to shake it for 10 seconds. If the dichloromethane layer is red, orange, you can classify the product as saturated. What is saturation? There are no double bonds if it is saturated. If you add another 0.5 milliliters of bromine water, cap and repeat, shake, observe the color, repeat the process up to 10 to 15 times. If after an addition of 5 milliliters or 10 times you've added bromine and you have no color change, there were no double bonds. As soon as there is a color change, you can stop adding bromine. You can say, yes, this has double bonds. Okay? And based on how many additions of bromine you do, you can rank which ones are more unsaturated, which ones are less unsaturated. And that's what you're going to be classifying in your table. You're going to rank how saturated or unsaturated the commercial product is. And then you'll be done. So that one, if you're, diligent, it takes about 20 minutes. So maybe 80, 85 minutes. Maybe we can leave early today. Depends on how much time I took for Prelab. 30 minutes.
So step 3 and 5 on there are different, correct? So you add the original 0.5 of bromine water, shake it, and then add another one.
Yes, up
So
to
you do 2 for sure, and then up to
10.
Oh,
Yeah, let's just say 10. So that we would end up adding a total of 5 milliliters of bromine. And if it hasn't reacted by the time we've added 5 milliliters of the bromine solution, then it's probably not going to react. Now, I will say aromatic molecules, I think toluene is one of the molecules he puts out for you as a commercial product. Aromatic molecules will not add Br2, so they require an additional catalyst. So you should see no reaction. Double bonds, I don't know if you guys learned this in biology, double bonds make things, especially biologically created double bonds are usually cis. They have a lower melting point. What does a lower melting point mean? Is it liquid or solid? Liquid. Okay. So the liquid commercial products are more likely to be unsaturated. And the solid commercial products, like butter, are more likely to have saturated fats, meaning they have fewer double bonds. It's just something to make a note of, when you're helping you decide which commercial products you want to test. I expect this liquid saffron oil to have saffron, whatever, oil to have, because it's a liquid, it probably has double bonds. I expect it to react with bromine. I do not expect this butter to have a huge reaction with bromine. That's it. You trying to what?
Probably shut us out the door.
Yes. Want to go to lab. I've told you guys you might get to finish early, so let's hope that I'm right. Right? That might be nice.